Thanks for giving us an opportunity to share about our Skylab, Smart Lab for the Green Future. Earlier, Adrian Chong has mentioned about the mixed mode ventilation, which is also in BCA Academy. So if any of you visit Singapore, please make a visit to BCA so that you can see BCA, the mixed mode ventilation, as well as the BCA Skylab, which is interesting lab to see for technologies, how we test it out. And earlier in the plenary session, Jonathan also mentioned about the 80-80-80, which is also part of BCA's main role to bring energy efficiency in Singapore. And BCA Skylab is focusing on the third part of the 80. Just give me a minute. Yeah, so this is about today's presentation. So I will introduce you guys about our Green Building Technology Department and BCA's Skylab objectives and where we stand in terms of testing and what are the test results and what things that we have tested and how it has been implemented in the real buildings. Because anything that we do in BCA, BCA is not having this Skylab just for making any profit, because our cost modeling is based on cost recovery model, and we want to see how the technologies are implemented in the real buildings. And just now when Adrian was presenting, one of the system that he has been using it in it is the desk queue system, which whereby the air comes at the occupant's level, which has been tested first in the BCA Skylab, and we see that's the real opportunity to implement more into the other buildings. So yeah, I'll go through it slowly. Yeah. So our department is called as a Green Building Technology Department, which is part of the Environmental Sustainability Group. So in our department, as I mentioned earlier, all our activities is based to see what is the output from our department work, to see an outcome at the impact at the national level. So today my presentation will be focusing only on a particular area, that is the BCA Skylab. Apart from that, we do have a GB program that is called as Green Building Innovation Cluster Program, where we also fund for technologies from R&D level to demonstration to level to the, and also to showcase the technologies. So like Adrian's project, we coordinate with NRF to get funding to implement the mixed mode ventilation. So like that, there are many projects that we have been working in parallel. And my colleague Shuhada is working with Adrian to get this project to be more successful and implemented in many buildings in the near future. So our outputs normally on the will results in demonstrations in the real buildings, and also to showcase so that the other building owners and developers will implement it in their own buildings, so that Singapore as a whole can move towards the net zero target that we are also working on it. So moving on further, so it's about the BCA Skylab. BCA Skylab is basically a comprehensive plug and play capabilities that can test for energy efficiencies in a real outdoor condition, and also it has more than 200 over precision sensors. This has been modeled after LBNL's FlexLab to test for technologies in the tropical climate. This helps. This Skylab is an instrumental for us to evaluate the technologies, how it works in the tropical conditions, because we do see some technologies that work in the temperate climate. When it comes to tropical climate, it has to undergo certain adaptations or change in the methodologies of how it works, so that our controls, so that it can be used in local buildings. And it also supports BCA's goal of improving 80% improvement in energy efficiencies. And it is a lab with the flexibility of testing multiple technologies in comparison with the reference cell, meaning that there are two cells that what you see in the image on the left side. So on the reference cell, all the technologies that is used in line with our green mark platinum level of buildings. And then it is compared with the advanced technologies that whatever that we have been testing it out, to see to what extent we can improvise the energy efficiency or push the boundary of energy efficiency. And so in this scenario, the reference is more important, because we are not comparing it with any low-end technologies. with the comparison itself, the reference itself is at a high standard of a green mark platinum level, and to what extent it further the technologies can improvise it to make the energy efficiency standard to be higher. And in the green mark, we also have we are pushing the boundaries of energy efficiency. So all these technologies will be instrumental to use it in our new buildings or even on the retrofit of existing buildings. Moving forward, yeah, so this is our value proposition. Basically, we support R&D by to develop technologies, and that can be validated or test bedded in a real environment, outdoor conditions. And we do support for demonstrations in real buildings. And finally, it ends into the deployment or into the actual buildings that will result in super low energy buildings. So that's how our Skylab LB has been propositioned, a value proposition, in order to test the technologies in real world conditions, adapt it to different operating setup, and also we make it as a comparative testing with reference to the reference cell that is of green mark platinum level of technologies. So at the end, it will provide us the outcome of validating the innovative technologies, developing new guidelines, and also for it's most important for the developers or even the building owners to make an informed decision. So that because here in this testing, there is no assumptions. Everything is practical, measured data, proves how the technology works and what type of adaptation need to be done in order to enhance its performances. Sorry. So what are the areas that we can test it out? Basically, it is on energy performances, BIPV performances, thermal performance, and visual performances. I do not want to go in detail on each and every parameters, which we can discuss it during the breakout session, or even if you are more interested, you can scan the QR code and you can express your interest for any testing or any questions. Please send it to us, then we will respond to you in time. Yeah. So as I mentioned earlier, this Skylab was developed in a technical collaboration with the LBNL's Flex Lab. So it's a lab that is used in a tropical condition to evaluate for technologies that can be used in Singapore. And it is able to test it out in 360 degrees. The lab is capable of rotating to 360 degrees so that we can test it out for technologies which is, like with respect to certain orientation or even with respect to the solar movement. Yeah, so even though we have high-end technologies, there are certain areas that we may not able to do it. Something like chiller systems or AHUs that cannot be tested or compared here because the space is only like 40 square meter. So those areas that still we are in the disadvantage that we may not be able to do it. But other than that, we are able to do testing in air conditioning, lighting, facade, PV, or integrated smart control systems that later on I will be explaining some of the technologies that we have tested so far. So who can benefit basically is like building owners, developers, researchers, technology suppliers, because sometimes the technology suppliers, they find it hard time to enter into the local market because Singapore is in a hub where if they prove it in local condition, then it is very easy to reach out to the neighboring countries like Malaysia, Indonesia. So we provide the testing and also we support on demonstration so that when it goes into the real building, then the technology will talk for its benefits and it will spread through the region so that easy for them to penetrate into the local market. And as a policy makers in BCA, we can also use this to benefit us to what extent we can lift up the energy bar, push up the energy bar so that that is whatever we make it as a minimum or mandatory. It is not just by assumptions, it's all a lot of data behind it to come up with the policy decisions. So Skylab is one of the area where it helps to make the policymakers within the BCA to come up with the guidelines. And what are the benefits? So basically, it's a improvement on the insights, and it is also BCA and Singapore Green Building Council recognition. Based on our test reports, the BCA Singapore Green Building Council is able to recognize and provide the certifications, and it is also verified under the real world performances. So if it performs in the lab, it should perform in the actual buildings when it is implemented, because it's not simulation or no assumptions in these scenarios. Yeah. So what we have been tested so far, there are many technologies we have tested, but I'm just listing out a few in relation to the topic. So one is the smart tamper. Basically, it is installed in all the aircon ducts in the Skylab itself on the test cell, and it is a AI-based demand control ventilation for fresh air and temperature or occupancy-based recirculated air control. And so it can achieve from a low airflow to a very high airflow based upon the static pressure control as well as the AI support to achieve energy saving as well as no compromise to the occupants in the space. And the next one is the model predictive control, which just now Adrian also mentioning that, which we have been used it before in 2017 or 2018. We have tested for our MPC test that is based on, because in most of the buildings, there are also a lot of questions just now in the chat session. Is the temperature 27 degrees? Is that too high? So we should change the mindset from just the temperature setting to a thermal comfort setting so that the system will perform and adjust accordingly to your temperature, your air velocities, so that it can help to achieve the thermal comfort. At the same time, it enhances the saving potential in the building depending upon the ambient conditions. Yeah. Then the other one is the passive displacement coil. So instead of using the air-conditioned FCUs or AHUs, we have tested out for passive displacement where there is no blowers inside to push the air. It is using the natural buoyancy effect of the air, like warm air rises and cold air sinks. And then we have seen good thermal comfort has been achieved, and also with the reduced energy consumption. And we are currently in the process of developing a technical guide to be part of the system that can be used in the Singapore so as to push the boundary of energy efficiency. Then the other system that we have tested is the advanced carbon capturing system. This was tested by professors from SUTD, where they just have some films to capture the CO2 levels when compared with the two rooms, where when the CO2 has been released into the two rooms at the same level. And you can see the graph that shows that the test cell where the CO2 level in the room is substantially lower. And the interesting part is this particular absorption can subsequently released in the environment of the plants, where that plants can absorb the CO2 to make the growth much better. So that is not just you absorb the CO2 and release it outside. So that's not the area that we are looking at it, because we want, as I mentioned earlier, we want to see what is the overall outcome and impact of the technologies that we test it out to the real application. So once you absorb the CO2 in the buildings, and then if you over the period of time when it's saturated, you release it to the plants, then that makes the plant growth better, as well as you really reduce the energy consumption in the building because of a lesser amount of CO2 in the buildings. Then the other testing that we have done is the desk view, where the desk will have the aircon that the user can adjust and according to his own preferences, the airflow, and it can also use to stop the airflow. I mean, occupancy sensors has been used to stop the airflow if no one is occupying it. And the same thing as I mentioned earlier, if we find it, this is and also it results in low noise level. So we find it, yeah, this is the way to move forward. So that's where we incorporate this technology into the mixed mode ventilation, where just now Professor Adrian was sharing more about this technology. And then the next one is the anti-thermal paint. So earlier in the second slide, I showed the lab with all the glass facade. Now you can see the entire facade with the concrete and tested for the anti-thermal paint. So as I mentioned, it is a plug and play concept. So even the facade, the lighting, the aircon, the plug loads, the layout, so for different orientation, the controls, everything is a plug and play concept that can be tested for multiple technologies to assess individual technologies or combined together. So that will give the benefit of the developers or even the building owners to make an informed decisions. So normally how we do the test is like first, before we do any testing, for example, if you have a technology to be tested out, first question we ask is, what are the questions posed by your customer, so that we find the answer for it through our measured capabilities. And then from there, we can decide what are the parameters that need to be tested out. And then we go through the detailed test procedures and methodologies to be tested out. And all these methodologies is according to the standards. Then we go with the testing, and we define the roles and responsibilities and monitoring period. And it's not a black box. During the testing period, the tester can see what we are testing, how we are testing, and it is also open to Singapore Green Building Council, so that they can, they have the visibility to see what we have tested and how we have tested. That will help to give them the green product labeling. And finally, it comes out with a final report that is shared with the any potential users of these technologies. That how, because in BCA we are not just interested in testing more technologies. What we are interested is to see how these tested technologies can be scalable and can be adopted in the real buildings. So that's where we need to do the first question correctly, like what are the challenges the technology faces in before applying it in the real building. Then we answer for that through our measured performances that will help the technology supplier to get into the market much more easier. So then now, I was asked to share some of the technologies. So the results. So I'm sharing the results of this smart damper, which I explained it earlier. So which is also using the. So basically, this smart damper, it can do online air balancing. That's the key capability of this. So in a building, initially, whenever the building is a commission, they do an air balancing. But over a period of time, when the building usage setting changes, nobody cares about the air balancing. So end up some areas will be feeling hot, some areas will be feeling too cold, because the air circulation within the building is not maintained at the same level as what it has been commissioned for, because of new partitions and other things that is coming up. So with these technologies, you are able to adjust the airflow according to the need whenever it is possible. As you see from the output, there are, we tested, there are 4 smart dampers installed, and we can adjust the airflow within a short span of time. Within 10 minutes, you are able to adjust the flow in different dampers, so that the system react to it and make the flow variable according to the need of the end user. So for example, giving you a simple example, like airport departure hall, if there is no flight, the departure hall may be still flooded with the aircon, whereas with this technology, it can be synchronized with the departure timing, so that before, say, 15-20 minutes, the things can be operated accordingly, so that the user in the departure hall may not even know that the space has no aircon before the time starts. Even another good scenario, which most of us would have experienced, like if a meeting room before COVID is like can take up only like 10 or 15 people, but because of urgency, few departments together in the same meeting room, maybe like 25 people occupied. So, but then with this, you are able to adjust the airflow accordingly, so that the areas which is not occupied, they can reduce the airflow and bring more airflow to the meeting room. That can help to enhance the comfort level. And on the testing done for the CO2 level, so the CO2 is released in the room, so that according to whatever our perspiration rate, and then you can see the trend, which is still maintaining according to the NEA's guideline. But the graph below shows that to what extent we can achieve the savings in the energy. So the ultimate objective is to ensure saving, but no compromise to your comfort or the quality of living. That's the most critical part. And the U curve on the left side indicates the thermal comfort, PMB versus the PPD curve, predictive thermal comfort. That is well within the range of good buildings. Yeah, so it can be applied in large office spaces and departure hall. And then the next one is the desk view, which I spoken earlier also. So here we can even maintain at a higher temperature, but still the thermal comfort is not compromised. So the graph at the bottom row shows that on the control cell as well as in the reference cell, we are showing that temperature at different levels. Like temperature at 25 degrees can achieve same comfort as the temperature at 24 degrees with the SQ systems. So that it shows that to what extent, I mean, how you manage the airflow within the building space, that will brings up the comfort levels at reduced energy consumption and also reduced noise levels. So basically, as I mentioned earlier, any job that we do, we are more interested in the net outcome, not just the output of our lab. So we are tested for a film, and that film, some of the test results, I shared it on the screen. I'm not going in detail on all the test results, which is not of least priority for this sharing session, but after the test results, it has been applied in many buildings in Singapore, so that it supports to the energy, overall 80% of energy efficiency improvement of what BCA is looking at in a larger scale. Similarly, the core painting, which we have tested out based on our test results, Singapore Green Building Council has given them 4 tick, which is the highest ranking that you can get for any product when it has been given as a certification. So again, it has been deployed now in 5 buildings in NTU. They're also expecting more orders outside Singapore, so which we are more happy to see the progress of the companies, because what is more interested is to how to develop our local SMEs in this sector. Yeah. So moving forward, we see there's a large potential. That's why we are coming up with a BE Innovation Hub. So there are 2 new buildings that is coming up in our BCA Academy, which will help to accommodate more innovation technologies and also bring more technological partners to work together with us to come up in a bigger way to improve the built environments, innovations, and also energy efficiencies.